finite term, f of mod of norm of f t square is a finite, less than infinity, not infinity, like less than equal to m.
So when you say less than or equal to m, so where m is finite, so it essentially means that your thing is there exists a finite m such that it is less than or equal to m, which means that you are looking at all trajectories that have finite. Yeah, but here you are also looking at the closure of such trajectories. So because the moment you take something like that, sine will not have a length, sine will have infinite length. So you are also including sine inside there. Even if you look at these trajectories, e raised to j omega t, they have infinite length. E raised to j omega t has infinite length. Doesn't it? Yeah. So this has infinite length. Now this vector space, you can define everything. You can define dot products in this vector space. You can define anything. You can dot product will just be this. So I can take a of t, b of t. I can take integral minus infinity to infinity a of t, or I can take a star t b of t d. So this forms a dot product between the trajectories a and b. So you can define a dot product like this. You can define, so based on the dot product, you can also define angle between two vectors. Yeah. So you can define everything with respect to this set. Yeah. And these set of trajectories kind of form the foundation of what we will be doing in our course here. Yeah. These set of trajectories will kind of form the foundation of what we will be doing. So we'll primarily be doing optimization over this set. Is that okay? Right. So you will be dealing with similar objects in 3 courses. Right. You'll be dealing with similar objects in your optimization course. You will also be dealing with these kind of objects in your nonlinear control course and in this course. So what are you currently doing in nonlinear control?
Just started. Sir was teaching something related to equilibrium and isolated points with equilibrium.
Who's taking the course this time?
Parijat sir.
Parijat sir. Right.
Can you explain that part, like limit point of sequence of all square integrable trajectories? What do you mean by that? What is the limit point actually? I don't get that part.
What is the limit point? Okay. Now in this set of trajectories, what are the points? Points are trajectories. Right? Now I can take a sequence of trajectories of this kind, e raised to minus 1 by kt sine omega t. Yeah. So now is suppose I put omega is equal to 0. Is this trajectory